Hi everyone, this is Praktis Sumatif, paper 2, question number 3. So in this question, we are given the gradient of the normal to the curve at a certain point, okay, and it's given by this expression. So we have to show that we can find the equation of the curve, which is y equals to 1 plus 5x minus x squared over x when it passes through the point 1, 5. So every time when we see the keyword gradient of the normal, gradient of the tangent, gradient function, we have to link with the first application of differentiation, whereby we will use this, I will use this, okay, as a way to solve the question that is related to the keywords that I mentioned just now. And then from here, I will mark down the 3 important elements that form the golden triangle to solve the question related to gradient function, gradient of tangent, gradient of normal. So over here, y. Now, we don't really know what is that. We have to prove that the equation is given by 1 plus 5x minus x squared over x. So we assume that we don't have y first. And then we have the gradient. Normally, we have to write down the gradient of tangent, but it's not given. And then we have to mark down the point, but the point is xy. But according to the question part A, the point is 1, 5. So let's put down 1, 5. And then we have the function, the gradient of the normal. Okay, therefore we draw the normal. Okay, so we have the gradient of the normal, which is x squared over x squared plus 1. Okay, with these 3 important elements, in order for us to find y, I must have the point and the gradient of tangent. However, I don't have the gradient of tangent, but we can find the gradient of tangent from the gradient of normal, because the gradient of tangent times the gradient of normal equals to -1. Therefore, the gradient of tangent will be the negative of the reciprocal of the gradient of normal. So in this case, if the gradient of normal is this, therefore the gradient of tangent will be negative, okay, of 1 over x squared over x squared plus 1. So go upside down. So this will be our gradient of tangent. So from there, gradient of tangent is dy dx. Okay? That means if we go down, we differentiate. From the gradient of tangent, we go up, we integrate. So in this case, gradient of tangent, we will have 1 and then plus x to the power of -2. Okay, so y will be integration of -1 minus x to the power of -2. And then let's integrate it. We have -x minus x. Increase the power by 1, divide by the new power, which is -1 plus c. Okay, so let's write properly. So we have -x plus 1 over x plus c. So let's substitute the point 1, 5 into the equation of the curve, which is y. So every time when I see y, I replace with 5. When I see x, I replace with 1. So we have -1 plus 1 plus c. Therefore, c equals to 5. So we will have y equals to -x plus 1 over x plus 5. Okay, but we have to show that the curve is given by this one. So since this is a single fraction, single term, so let's combine these 3 terms into a single term. So we will have, find the lowest common multiple, which is x. So we will have -x squared plus 1 plus 5x. Let's rewrite over x, yeah? Let's rewrite from constant to the power of x in the ascending order. So we have 1 plus 5x minus x squared over x. So we have just shown that the y equals to the expression given. Okay, so that is the answer for part A. Next, part B. We have to find the equation of the tangent to the curve at the point where x equals to 2. So for that, so now we know that the curve is 1 plus 5x minus x squared over x. Okay, and then we have to find the equation of the tangent. So to find equation of the tangent, okay, let's just put down the important elements first. We have this, we have the gradient of tangent, and then we have the point x, which is 2. But what is y? Don't know, but we have to use this to substitute in order for us to get the point, right? Reason is to find equation, we must have two things. One is the gradient of tangent, another one is the point. So these two things must be found. Okay, so how do we find? So the gradient of tangent, okay, we don't have to differentiate it because it's already given right from the start. We have the gradient of normal, and therefore gradient of tangent will be this, negative x squared plus 1 over x squared. So let's just put that. Okay, negative x squared plus 1 over x squared. All right, so let's find the gradient of tangent. So when x equals to 2, the gradient of tangent will be negative 2 squared, which is 4. 4 plus 1, 5 over 2 squared. So it's 4. So 5 over 4. It's negative 5 over 4. And when x equals to 2, the y will equals to 1 plus 5 times 2, and then minus 2 squared over 2. So 1 plus 5 times 2, 11. 11 minus 4, so we have 7 over 2. So the point is 2 and 7 over 2. So with this, we can substitute into y minus y1 equals to mx minus x1 to find the equation of the tangent. Therefore, y minus 7 over 2 equals to negative 5 over 4 x minus 2. So get rid of the fraction mode, multiply both sides with 4. We will have 4y minus 14 equals to negative 5x plus 10. And therefore 5x plus 4y minus 24 equals to 0. So we have found the equation of the tangent.